Hello, welcome back to my channel. I was busy. I didn't uploaded a video for a long time. I think more than 1 month. So let's start again on the first day of 2026. So today we are going to discuss a very important topic. What is the least square method and the corresponding curve fitting? Let's take with an example. So suppose this data is given. What is that? I have a 99, 2000, 2001 to 2005 data, and for each year I have the production of paddy and also the corresponding rainfall. Okay, now first let us understand out of these two variable y and x, which one is independent and which one is dependent. So independent means it doesn't depend upon anything. So rainfall, it doesn't depend upon anything. So rainfall is my independent variable, right? But depending on the rainfall, my production of paddy varies. So if it is a moderate, the production of paddy will be moderate. If it is less, production will be less. If it is more, then also production may be less. Excuse me. So this is my dependent variable. Now, here I have a model, something like yi equals to capital yi plus ei, I from 1 to 1, 2, 3, 4, 5, 6, 7. 1 to 7. This means 1 and then gap of 1. So I have this data. And since I have only two data, so we call it simple linear regression. Now why simple? Only one variable, y and x. And why linear? Because I am assuming a model yi equals to a plus bxi for I from 1 to n, where a and b are unknown constant. Now let's see how we can how we can work with our model yi equals to small yi equals to capital yi plus ei here. So let's do that. So yi equals to y, capital yi means a plus bxi, as we have assumed a linear model, plus ei. Now what is our goal? Ei is the error corresponding to the ith variable, meaning I know the production of paddy is 17.5 in 1999. Now when I fit my model, according to my model, what is going to be the production of 1999? The gap between yi actual versus observed, this is called ei. Excuse me. So the gap between actual versus observed, that is my ei. Now as you can simply understand, what is my goal? My goal should be minimize the error. My goal is to minimize the error. Now that I can do simply summation over I from 1 to n ei, which is summation I from 1 to n yi minus a minus bxi If we call this as S, my goal is to minimize S. But there is a problem. Let's draw a picture and let's understand the problem. So basically what we have here, we have something like this. This is my rainfall. So this is Xi, this is Xi's, and this is my production of paddy, which is Yi. So I have some data like this, 1, 2, 3, 4, 5, 6, 7, suppose. So what is this? This is my X1, Y1, meaning corresponding to a 91, this is my rainfall corresponding to year 1999, and this is production of paddy. Similarly, this one is X2, Y2, this is X3, Y3, like that. I have 7 points. So what I'm trying to do here, I want to draw a straight line between them so that the perpendicular distance from the point on the line, perpendicular distance from the point on the line is minimum. That is what we are trying to do. Let's see, there is a problem. This is like, suppose the upper part of this line I'm assuming at plus, and the negative part I'm assuming as means. This is, if this is my positive part, this is my negative part. So it may so happen the sum of the positive parts equals to the sum of the negative parts, and as a result EI may be 0, but there is a lot of error like this. So what is my next step? My next step is, instead of EI, I am trying to minimize EI square. So I am squaring it. So if there is any negative bound, that is getting positive, and then I am trying to minimize it. So I have two equations, two unknown. So first one is ds dA equals to 0. This is equation 1, and then ds dB equals to 0. This is equation 2. These two equations, let's try to solve these two equations. The first one is dSA by dA by 0, and then ds by dB equals to 0. So let's solve this. So what will be ds by dA? This will be 2 I from 1 to n yi minus a minus bxi. Then we differentiate a with respect to a, which is minus 1, and that is equals to 0. And if you simplify it, it becomes sum from I from 1 to n yi minus n a minus b summation xi equals 0, or summation yi I from 1 to n. If I take this to that side, na dividing n dividing by n of both sides, we have y bar equals to a plus bx1. This is my first normal equation. Now, this is the first normal equation I got from ds by dv. Similarly, from ds by dv, I will get another equation. What's that? ds by dv equals 0 gives 2 and then I have to differentiate bxi with respect to b, which gives minus xi, and that is equals to 0. Now, if I expand it, it becomes I from 1 to n xi yi a xi plus b xi square. So this is my second equation. So I have two equations, two unknown, and I solve for a and b. Two equation, two unknowns. Solve for a and b, and we call that a hat and b hat. So my new equation being y I equals to a hat plus b hat xi. Now if I give a xi, we will get the corresponding yi at a hat plus b hat xi. That's it.